Suppose researchers want to construct a confidence interval for the mean pounds of food consumed per day by an Alaskan brown bear. A random sample of 7 bears yielded a mean of 63.5 pounds with a standard deviation of 9 pounds. Assume the population is normal, and let's construct two different 90% confidence intervals. First, we'll assume that 9 pounds is the population standard deviation. Our AP confidence interval formula produces an interval estimate of the mean food consumed per day of between 57.9 pounds and 69.1 pounds. The margin of error is 5.6 pounds. But the population standard deviation could be significantly more or less than our sample standard deviation of 9 pounds. We don't really know. William Gossett's t-distributions help quantify the uncertainty of how far the true standard deviation is from our sample standard deviation. Here's what we should put into the confidence interval formula. We need the critical t-score from the specific t-distribution with 6 degrees of freedom. This would be 1.943 standard errors away from the unknown mean. In this case, our interval is from 56.9 pounds to 70.1 pounds. Why does this interval need to be wider than the z-interval, and why is the margin of error now 6.6 pounds instead of 5.6 pounds? Well, I'm glad you asked. The original margin of error of 5.6 pounds in the z-interval is due to the sampling error of the sample means, how much random fluctuation can exist for the middle 90% of sample means about the unknown population mean in the sampling distribution. But this is only accurate if we for sure know that 9 pounds is the population standard deviation. Well, we don't know that. And the fact that the population standard deviation is likely something other than 9 pounds adds more random error. Gossett's t-distributions were developed to incorporate this additional error. So the extra 1 pound width of the margin of error accounts for the additional random chance error contributed by using a sample standard deviation in place of the true population standard deviation. T-distributions take away such worry and give us an accurate interval estimate of the unknown mean.